I'd like to introduce Kevin Skow. He will be presenting National Weather Service post-event aerial resources. Go ahead, Kevin.
All right, thank you, Mike, and thank you for everyone for joining today. The impetus of this talk actually started with a topic on this that I presented to our emergency manager group for our spring seminar, and it dawned on me that there's a lot has changed when it comes to our aerial surveying capabilities post-event over the last decade or so. So it'd be nice to take kind of an overarching look at what we have available for us when it comes to post-event storm surveying. But before diving into all the good information here, just a word about aerial data is that it really isn't the end-all be-all for finding tornado tracks or diagnosing for post-event storm surveying. When it comes to tornadoes especially, there's a lot of different factors that can limit what you can see in aerial data, that being most commonly the land cover, especially grasslands and harvested croplands that are difficult to disturb, the time of year with green vegetation being easier to disturb. Weak and broad tornadoes, especially with some of the lower resolution data, can be harder to discern in these data sets. And then of course, imagery resolution can impact whether or not you can see finer scale details of a particular event. And I'd like to hit that the highest quality storm surveys really do incorporate all data sources to construct final storm damage paths, that being the ground survey, the aerial data, and then also event photos that are taken afterwards. So really the aerial data is just one of these three main data sources, this trifecta of data sources to construct the most accurate damage tracks you can. So with that being said, these are the different types of platforms that we have available to us, and their predominant pros and cons. The first of all, the most common probably nowadays is the satellite imagery. The greatest pro it has is those large coverage areas, especially with certain types of satellites. It is very easy to do pre and post event comparisons. But the Achilles heel of a satellite is its cloud dependency. And so if you have cloud cover between you and the satellite, you're not going to obviously see anything. And some satellites are non-taskable. They are on a fixed schedule, and so their availability can be limited as well. More commonly, more recently, we have the unmanned aerial systems, or UASs. They have very fine detail. We're talking centimeter resolution. Real-time data acquisition, you can see the data as you're capturing it, so you're not having to worry with satellite imagery of having to do processing time. But the limitations of UASs are, of course, wind. High winds will ground most smaller UASs. And then they have limited range and battery life as well that you need to be cognizant of. There's also the added issue of privacy concerns, especially right after an event as well, so that you need to take into account. One of the more older methods we've had for aerial photos that's still around is the Civil Air Patrol. Its biggest pro or biggest advantage is it has decent resolution, especially for most tornado track surveys. And again, like with UAS's real-time data acquisition, you can get the photos the day they are taken. With Civil Air Patrol, obviously you're using crew and you're using fuel and using an aircraft. So these tend to be reserved for the higher end events because they just cost money. And the photos, especially if they're taken off nadir or are taken at an angle, are going to require adjustments, and they're not as easy to import into the DAT and use into the damage assessment toolkit. And finally, there is the National Agricultural Imagery Program, which I'll touch more on here in a little bit, and other third-party sources. And these have very fine detail to them. The coverage area can be pretty widespread in terms of, some of them are very targeted, some of them cover large areas. But the problem with these sources is, especially when you're talking about trying to get the track done as fast as possible, is that can be a large time delay with these sources. We're talking months or even a year potentially to see some of these data sources. And they may honestly just fail to sample an event. A lot of times these third-party sources are reserved for very high-end events. So we're not talking about surveying EF0, EF1 tornadoes with some of these higher-end sources. So we'll start first with the satellites. The most common one you can use for post-event surveying these days is the Sentinel-2 Satellite. You can think of it as the Europeans' version of our Landsat satellite, but it has better resolution. You can access it. The easiest way to access it that I have found is called the Sentinel Hub or the EO browser, and the link's available here at the top of the presentation. The resolution of this satellite is 10 meters, so it is on the coarse side, but it has a lot of advantages to it that allow you to really see fine scale details, even given its resolution limitation. It samples a given area continuously every 3 to 5 days. And this data has been archived online since about 2017. So we have about 6 years worth of data that you can go back at any time and go and look and do some analysis on. And this archive is absolutely amazing when it comes to looking for pre-event data and locating subtle damage that you may not see in a single image analysis. And I'll show an example of that here coming up in the presentation. This data is also easy to view in the web browser through that EO browser or the Sentinel Hub, and also directly in the damage assessment toolkit. You can actually load this data directly into the DAT and draw your tracks on it. The biggest con, obviously, it's not taskable. It's on a fixed schedule, so you need to wait for a clear pass, and this can take weeks, even sometimes over a month to get a clear pass. It really depends on cloud cover. And the resolution does limit you to basic path analysis. We're not talking about being able to ascertain EF ratings or diagnose to that degree of detail with this satellite. But you can construct your basic paths here, and this is an example here from one of our March tornadoes down in southeast Iowa here, where you can see a very clear path running from southwest to northeast. You can actually see the individual cycloidal swirl marks as the tornado is moving through these barren farm fields. So all you're seeing is corn stubble being aligned there in the Sentinel satellite. So again, the best uses for the Sentinel are going to be determining damage source. You can pretty easily determine if it's tornado versus downburst wind damage. Adjusting track lengths and widths for already ground survey tornadoes, it has great utility for that. And you can draw your basic tornado path outlines and especially find even new tracks you may not even know existed. Here are just some of the examples of Sentinel data from the last few years. The image in the upper left, is a downburst hail swath across northeast Iowa, where you can clearly see the area that was taken out by this hail core. Flooding. You can do pre and post event flooding comparisons, and this is an example here in the middle of our Mississippi River flood by the Crosse earlier this spring. And even on a broader scale, you can pick out the wind damage from the central Iowa derecho back in August of 2020. It very clearly shows up in this before and after comparison loop. So the utility of the Sentinel is not limited to just tornado tracks. It's limited to any type of event that you might want to do analysis on as well. When it comes to actually loading the Sentinel imagery into the DAT, this is just a quick loop I did of loading that imagery in. You would go to the Add Data button on the top of the screen, and then it'll change the source to ArcGIS Online and type Sentinel. And then you can click the Add button there, and it will load the Sentinel data in there. And if you're looking for data that's older, like in the past, you can go through and use a date filter to change the date of the Sentinel imagery that's being viewed. And I can go over that later if anyone's interested or wants to go over it in detail. The next type of satellites that we have at our disposal are taskable satellites. And this has been around now for actually 10 years now. We've had this ability to order satellite data for a given region using either the WorldView or Spot satellite, and there might be a couple others nowadays. And it'll task the satellite. It'll actually reposition the cameras on the satellite to go to these areas and sample what we want it to look for. And you can order this through the USGS as well to this link. And actually their site is down today for maintenance, so I can't show it. But the resolution of these satellites is much better than the Sentinel. The WorldView imagery is roughly on the order of 1 meter resolution if you're doing kind of a pan sharpened image where you're combining the panchromatic or the black and white imagery and the multispectral or the color imagery. If you combine the two, which is most common these days, you're roughly talking about a 1 meter resolution image. There's also the spot satellite, which might get used every now and then, that's slightly lower. And one also caveat is that since these satellites can reposition their cameras, this resolution may vary slightly because you're not quite at nadir with some of those pictures. So something to be aware of, but you're not really notice it too much. And again, the sample interval is user defined. You can specify if you want it to be tasked multiple times, like say if you're trying to sample a flood that's happening. But most often you just specify that the next available clear image is what you want. And the pros for these satellites, great resolution for surveying purposes, and the Worldview satellite's kind of the gold standard for that. And again, taskable in that it'll continue looking for data until it acquires a cloud-free image. So oftentimes, hopefully, you can get an image faster than you could off the Sentinel, just kind of hoping with the Sentinel that you get a clear slot. The cons with this data, unfortunately, when we have the DAT upgrade a couple of years back, it broke our ability to import this directly into the DAT. There is a workaround where you can download the data, process it in ArcGIS, and then re-upload it to the ArcGIS servers. And that's a bit cumbersome, and I didn't show it here. But you can do it. If you have an image you want to get into the DAT, you can load it in there as an overlay. And there's also the fact that you need to order this data, and you need to order it, I say, correctly or properly. You need to be able to target those areas that you want the data very precisely. If you select a large area when you're doing your ordering, the satellite may struggle to capture the image that you actually really want. And the best use for these is very similar to the Sentinel. You can do more fine-tuning of the track outlines and hopefully get the imagery faster than you could with the Sentinel in the order of hopefully less than a month. And here's some examples of the Worldview and Spot here on the right-hand side, where the Worldview imagery, this is an old panchromatic image of a tornado track. And you can tell with the Spot, obviously, the resolution is much lower, but you can still easily pick out the track going through the farm fields. So in this example, this is just assuming that you actually had the imagery processed through GIS. You would go to that Add Data button again, and you would actually go to your personal content in the search bar. And then if you've already uploaded it to the ArcGIS servers, you can just click Add, and it would then show up there in the map, and you could analyze it right there. So that's actually a local file that I made using this imagery just to show for example's sake. So it is possible to do. More recently, we have private and partner UASs, and this is coordinated locally by your WCM or other contact. The resolution of these can vary quite a bit and really depends on the altitude of the drone or UAS and the angle that it's viewing. And of course, these are on-demand type platforms that are best used for immediate aerial imaging needs. Like say you're out there on the ground survey and need to see where the track went, you could send up the UAS and take a look right away. And there is a note, we're still working as a weather service to get a handle of how to best handle UASs as far as requesting data. So as it stands right now, you can't explicitly request UAS operators to conduct flyovers across damaged areas, but when you do send out calls for post-event imagery or damage photos, you can mention UASs as one possible data source. And I grabbed that right off of our official post-event storm data page as well. You can go there for more information if you're really interested. As I talked about earlier, there is the Civil Air Patrol, and you have to coordinate those Civil Air Patrol requests through the CR ROC. And the platform they use in the past has been manned, but they are moving towards UASs as well for their imagery acquisition. As with UASs, the imagery will vary quite a bit depending on the altitude of the aircraft. And as with UASs, again, immediate imagery needs, you can get the data relatively quickly and process it in GIS as well. And these are some examples. These photos are actually over a decade old, but they still show a great, they still show what Civil Air Patrol flights are capable of if you do need to utilize them. And now this is probably something most folks haven't heard of, is the National Agricultural Imagery Program, or the NAIP. It's not meant for storm surveying, but I found it to be a really nice resource, kind of a dark horse out there for aerials for surveying. You can access it through the URL here on the screen. The way it works is it's a program through the USDA to sample it was intended to sample cropland in the late summer to early fall periods across the United States. And they use aircraft to fly across the United States and take pictures of the areas. And this is coordinated on a state level. So each state contracts with the USDA to acquire this imagery. And right now the resolution is 60 centimeters, which is really good. And prior to 2019, the imagery was about 1 meter. The big issue is that they do the flyover once. And so you get one shot per year roughly to get these tracks sampled, generally again, the mid to late summer. And the resolution is quite outstanding for surveying purposes if you happen to sample them. And you can discern tree fall orientations and even subtle damage patterns. And they do have an archive of this imagery dating back all the way to 2003. So if there's a track you wanted to go look at since then that may have been sampled by the NAIP, you could go back and look at it. And the big con, of course, is the delay between the event and imaging. They'll capture this data in the late summer to fall time frame, and it may not be available till March or April of the next year potentially. They're getting better at getting the data out sooner, but there is a solid 3+ month lag to get this data out. And not all states are sampled each year. Again, each state contracts with the USDA to get this data, and not every state is sampled every year. So you got to be aware of that. But their website is undergoing a really great upgrade, and you can actually see which states have been sampled, the current states that are being sampling right now, and states that have been sampled in the past. And this is really great for longer term event assessments. We're not talking about something you're going to be able to use a week after the event. We're talking this is over the winter time, and you're going back and looking back at your tracks and seeing what needs adjusting. And these are just some examples of the NAIP data from this past year across Michigan and Wisconsin. These are just some nearby tracks that I went and grabbed. The top left one is the Gaylord tornado from last year, and then we have a couple Wisconsin examples, tornado tracks across Wisconsin that showed up very well in the tree fall patterns as well. So you can easily see the convergent tree fall patterns with these, especially this right-hand image of the tornadoes out there. And as with the Sentinel data, you can easily now load the NAIP data into the DAT. I would recommend using the link here at the bottom of the screen because it is the most up-to-date NAIP data set. I know that you can do a search for NAIP data sets in the DAT, but I've noticed that they may not be fully up to date. So to do that, you would just, again, go to that Add Data button, which is going to be very popular if you use that, and then click the URL button, paste that URL in, and it will grab the image from the USDA servers, and then you can use it to assess your tornado tracks as well. It's very easy to load in quite quickly. And finally, the last option that we have at our disposal is something known as gray sky imagery. It's through the National Insurance Consortium Board that they contract out to fly aircraft very low over areas that are damaged and capture incredibly high resolution that they do share with NOAA and the Weather Service. And the resolution, I haven't gotten an explicit answer, but based on what I can tell, it's roughly 5 to 10 centimeters. And of course, since they're flying these tracks with aircraft, it's they take it immediately after an event as cleanup has hardly started. The pros, as you can see in the image to the right, this is Andover, Kansas from April of last year. The detail is quite amazing. You can actually think about starting to rate structures accurately with this kind of data. And the service, according to their website, is designed for rapid turnaround time. So they post it within 24 hours of capturing. The cons, of course, it is reserved for the very high-end events. And to my knowledge, at least at the WFO level, we really don't have any control as to when or where this imagery is captured. It's up to the group itself to determine when they want to capture it. And I don't know that we're actually even alerted to this imagery being available. You need to actually search for it in the DAT. But it allows for incredibly detailed assessments of events after they happen. And these are just some examples here of some of the imagery that's been captured over the last couple of years, like the Andover, Kansas tornado. We're talking, you can actually see individual corn stalk patterns here in the swirl marks in the field. and seeing going down to incredible detail on these tree fall patterns in Missouri and structural damage down in Mississippi from back in March of this year. So the imagery is out there. It's just a matter of, is it available? So this is how you would load the imagery into the DAT. You would go back to that Add Data button on the top right, and then you would search under My Organization for Gray Sky, because it's shared only with NOAA, so you got to be under My Organization. And then it's under that VXL Gray Sky. It's kind of weirdly named, but it's in there, and you can load it in pretty quickly and use it. You can see what events are available. I think that's the entire archive of gray sky imagery, at least for the last couple of years. Again, not terribly familiar with it. I know it's available and I've played around with it, but I'm certainly not the expert in the gray sky imagery category. Oops. So this is just an example of imagery resolution comparisons to see just the breadth of the type of imagery we have available. This is from our Tomah, Wisconsin tornado in the forested regions. This is the Sentinel data. Obviously, you can tell there's something there. Obviously, if you did before and after comparisons, you would easily tell there's a track there. But when you go from the Sentinel at 10-meter resolution down to the NAIP imagery at 60 centimeters, it's night and day, quite literally, where you can tell from this data. So it shows the type of imagery we have is really quite varied. And going back to, this is Mayfield, Kentucky, back from December of 21. Again, this is starting with the Sentinel data, the coarsest resolution data you're going to have available. If you were doing before and after comparisons, you would obviously be able to tell there was significant building damage, but you'd probably be limited at that. But then this is the gray sky imagery from that same event at the same level. And obviously it's night and day difference for what we have available at our disposal to use in the DAT. So quite remarkable, the type of imagery we have. And I've been asked, when should I use certain types of imagery? And the answer, of course, unfortunately, is fairly complex. It depends what you want to get out of the imagery. And I kind of had to sit here and think about this for a while, and I came up with 4 different categories of what is the highest priority for you when it comes to the aerial data? Do you want something that has great detail? Do you want something that has the best coverage? And the answer isn't the same for each type of product. Obviously, you can see some trends here where if you have high impacts and high detail, you're talking about using on-demand systems like Gray Sky or UASs or Civil Air Patrol just to get out there as fast as you can, especially with urgency. The satellites are not going to match up with anything that's on demand like Civil Air Patrol or Gray Sky or UASs. They're just, they takes time to get the satellite in position, or just wait for the satellite to do a pass. The coverage, you can see it almost flips from the impacts side of the house, where the Sentinel data is going to give you amazing coverage, and you're going to be able to look anywhere you want with the Sentinel data, whereas Gray Sky will be quite targeted. They're going to sample just the tornado track that they want to and nothing else. So if you have another area that you're interested in to go look for damage that you didn't know if it's a tornado or not, you're not going to see it with the higher resolution type imagery. So again, it's a kind of a multifaceted answer to the simple question of what do I use when. So now, what in the heck do we actually use this data for? Came up with 4 different options here. The biggest one is filling in the gaps that you simply don't get with a ground survey, and being able to fine tune the various tornado characteristics, its length, its width, and also producing high quality tracks. You can find weak tornadoes that you may not see from a ground survey, you may not be able to discern, and damage discrimination between downbursts and tornadoes. And even in rare instances, you can assign an EF rating for these briefer, weaker tornadoes in the absence of ground photos. And I asterisk that because really the gold standard for EF ratings is still ground surveys, long and short. But there are times you can discern damage intensity, especially in, say, forested regions, where you can assign an EF rating fairly nicely from just satellite imagery, aerial imagery alone. So we'll go over each of those 4 bullet points here with different examples. This is an event from our Northeast Iowa regions back in April of 2022. where the ground survey initial track saw damage and tornado damage in a stream bed area off in the distance from the road, and couldn't see any damage anywhere else. So the initial track that we published was that blue line right there. And if you're looking, you can see obviously the tornado track goes much farther than it originally did and simply didn't really hit anything that we were aware of. It does go over a farmstead there on the bottom left of the image, but we had no reports of damage there, and the ground survey team simply didn't go over there. And so this is a great example of being able to fill in the gaps and add considerable detail and considerable value to our damage survey process. I talked about before and after comparison. This is a really nice example of doing that. This is a picture of a tornado track across our hilly terrain region across west central Wisconsin from September of 2021. And if I were to show you this right now and ask you where the tornado track is, you would really struggle, especially because we have all these ravines and river valleys in there, and it's really difficult to pick out anything that stands out. So when I toggle on the before and after comparison, suddenly something really starts to stand out there in the center of the image, where you start seeing this area of enhanced damage that shows up there that you wouldn't have been able to glean as easily from a single image analysis. So this is where the Sentinel data really shines, is this before and after comparison to pick out really subtle damage patterns that you just wouldn't see from a single image analysis. This is one of my favorite examples. This is using a false color imagery. That's why it's all red. But this was back in the December 15th, 2021 derecho event across western Wisconsin, where we had snow cover on the ground for the both before and after comparison. So this is the after event image from December 29th. And again, looking at this, it's kind of hard to pick out something as far as a track that shows up there. But when you toggle before and after, those tracks really show up quite nicely. You can see the two separate tornado tracks that show up in the trees, and you can really see the beginning point starts way at the bottom left of the image, where you would have no way of figuring that out in a single image comparison. Filling in the gaps again, trying to figure out where a tornado might have started. This is an example from Marble Rock, Iowa in August a couple years back. You can see the tornado track coming out here from the bottom right of the screen, and it starts somewhere here to the west of the town of Marble Rock, but where exactly it starts is a bit of an unknown. You can see, potential damage up here north of the river. You can see maybe some swirl marks going on here to the south of the road. But this track up here looks kind of interesting. This is looks like maybe a small track in the fields north of the tree line here. And maybe that's where the track started. And honestly, that was not a tornado track. This is before and after imagery, and you can see that feature was there both before and after the tornado track happened. So we know that's not actually made by the tornado track itself. And in the end, we just extended it a little bit farther to the west on that little small area of disturbance there in the cornfields. And there's also some evidence of an additional maybe vortex wrapping in just to the south of that as well. But we characterize the damage to the west as inflow and to the north as downburst, and the feature here to the northwest, which kind of looked interesting to start off with, was not even a tornado track at all. And I talked about also high resolution tracks, and this is an example from our Boscoville tornado in southwest Wisconsin back in August of 2021. And this was the initial ground survey that we did. And you can tell right off the bat that we're quite limited by the road network out there in southwest Wisconsin. It's very driven by the topography of the area. So the points are very much aligned with the roads and not much else. And the line that we initially drew for a track there was pretty crude, but did the job quite nicely. And then we have the Sentinel data that came in. You can see much finer detail. You can see damage that extends beyond our line of sight from the roads. And from that, it was a little bit difficult, actually a lot difficult, to ascertain downburst wind from tornado. But from all that work, this was the tornado track that we came up with. And you can tell it tells a much better story of the tornado a much better narrative of the tornado and the type of damage we saw than just a simple line or even just the points themselves. And I have an example at the end of the story, end of this presentation, of a story map that we made of this track and how we're able to incorporate the Sentinel data in the actual story map and the DAT data to show how we did the survey. It's quite informative, I would like to think. The second bullet point we talked about in the earlier was finding tornadoes that we didn't know existed. And here's an example from North Washington, Iowa, following that December 15th derecho of a tornado track that only lasted for about 2 miles and just stayed in the farm fields and didn't really hit anything that was observable from the roadways. But the tornado track stands out quite clearly from the Sentinel data taken a couple of weeks later. And I wanted to also go through the process of finding these weak tornadoes, as far as how to hone in on the areas that you should be interested in, and just going through the whole process, because I think it's rather informative how to do this. So this is an event back on April 12th, 2022 across Winona County, Minnesota. And we're going to start off with the radar analysis of the event to figure out where we want to go look for any weak tracks. And really, the product to key in on here is the correlation coefficient, because these smaller scale tornadoes have circulation diameters that are going to be, that the 88D is really going to struggle to resolve unless it's tied to, say, a mesovort or a mesocyclone itself. And this is a squall line. This is a squall line coming through. You can see we have the classic shear dominant portion of the line moving into southwest Winona County right there. So just based on our 3 ingredients analysis, and the shear was outstanding this day, you would be looking for tornadoes along and north of this bow apex potentially. And just zooming in on that area a little bit more, starting at 440Z, nothing to really note in this correlation coefficient data. But as you move forward to 1 minute later, and again, this is on Sales 3, and I'm a really big proponent of Sales 3 data when it comes to trying to find these tracks down, you suddenly have 2 small areas of interest that pop up there on the back edge of the line. They don't really match up well with the velocity imagery, especially that left one. It really doesn't stand out too much. It's lagging behind whatever mesovort that the radar itself actually could pick out. And then moving forward in time, a couple minutes later, you can see clearly we have 2 debris plumes that are within a couple of miles of each other, wrapping to the northwest and north. And they only last for another scan or so before falling apart. And so these 2 little small debris plumes lasted only through a typical 88D scan time. They were completely observed during those 3 sales cuts, and by the next volume scan, they were gone. So very subtle, very quick debris plumes that went up, and even by the end, finally, you can see that southern debris plume started finally lining up with the couplet that we were seeing on radar. But earlier on, it wasn't lining up at all, and it really was offset from whatever vortex was there. So my process is, hone in on those debris plumes, because those are going to match up closest to where the tornado would be, and then quickly sketch out outlines of where you think the track should be, and get a rough idea. And I'll be old school and even sketch these out on paper sometimes, but it's nice in the GR analyst that I'm using here that you can toggle off the radar data and then see roughly what features you want to be looking for, any structures nearby, or just get an idea of where you want to look in the aerial data for these tracks. So this is just using the Sentinel EO browser that I talked about earlier on about locating those tracks. So this is just a quick loop here of going through the process on the EO browser. You have to select your date range there on the immediate Discover tab. And on this, I'll go through and quickly choose April, just the April 2022 data that's available here. Go through that. And then you do a search, and you'll see the available imagery pop up on the left side. And the closest available imagery we had after the event was April 21st, so about a week or so afterwards. And it's kind of dark, so you can adjust the gain and the gamma on it until your heart's content and make it a little bit brighter for you to see the data offhand. And then again, using those tracks we were drawing earlier, kind of zoom in on the area of interest, and then you add that to the compare tab there on the top panel, and then start going backwards in time until you find a pre-event image. In this case, we were very lucky to have one from April 11th, just a day before the event. And now in the compare tab, you can see both image sets are available there, and you can toggle them on and off using the slider tab there, and you can go back and forth and see any features that change. And something pops out right away there where I'm highlighting here with the mouse. There's some track that's going to the northeast, roughly in line with where we expected something to be, but it's really faint. If I were to use pre-event imagery, post-event imagery alone, you may not see this feature. It may look like just another ravine. And you can see it goes all the way down. It has a bit of a turn to it here where it turns to the north, goes north, and then turns more to the northeast and heads out here. The second track is even more harder to see. That's the town of Fremont right there. If you go before and after, nothing immediately stands out, but if you look there to the north of the town, there's this really subtle line going north-south. It's very narrow, very faint, and that's actually the tornado track right there. And you can actually see tree damage here that I'm highlighting here with the mouse. If you go back and forth, you can see there's a luminosity change in the trees right there. And that's actually tree branch damage. I went out and looked later on, and there was actually trees that were damaged in there. And if you look to the south of the town, you can see this faint line, this faint smudge that kind of clips the east side of the town there. And that is actually the tornado track itself. And it goes all the way due north, right in line with what we expected from the TDS trajectory there as well. You can kind of see, you can toggle back and forth. That's the, that was the tornado track. So again, when it all wrapped up, these were the two tracks that we saw, the western track and the eastern track, looking at the before and after comparison there. Again, very faint, especially with that eastern track. That track was probably on the neighborhood of only maybe 15, 20 meters wide at best, probably closer to 10 meters, honestly. It's so crude. The western track stood out much better. And these were the tracks that we eventually generated in the data and published to the world for those two small tornadoes that we initially didn't know existed. That we did send a ground survey team out the day after to look for these, but the damage was so weak and so sparse. And again, we didn't have the Sentinel data to help us narrow down these regions a bit more, that the ground survey team simply just didn't see anything. And for comparison's sake, these were the two lines that we drew initially from the radar data alone. You can see they line up decently well with the ground survey tracks. It's a pretty good fit. And sometimes you get more than you ask for when you start looking for these tracks. This is for those of you who are in Des Moines, remember this very well. Back in August of 2014, we had a QLCS roll through central Iowa. And in the days after the event, we really didn't have any tornado reports whatsoever. And it wasn't until the next year when we were reviewing the NAIP data that we suddenly realized there were tons and tons of small tracks, and actually some of them quite long tracks associated with this QLCS. And we ended up, after months of analysis, counting 111 circulation damage tracks. And we weren't going to call all 111 tornadoes. That would be, oh wow, that'd be quite something. But we still eventually called 35 of them tornadoes, which set the Iowa tornado record, the state Iowa tornado record, up until December 15th, 2021. So we had a record tornado event that no one knew existed. So that's really opening Pandora's box there for looking at this data and trying to figure out what actually happened after an event. And these are some of the pictures we got from that August 31st event. You can see clearly these look like tornado paths, especially the right ones, and the bottom one even looks multi-vortex. So these weren't small little tracks like the top left one. These were solid tracks at times going through farm fields and even causing structural damage. The third item that you can look for is damage discrimination, especially when you're trying to determine tornado from downburst. And this is one of my favorite examples. This is actually off of Google Earth from Muscatine, Iowa, back in October of 2016, where this track is going just to the northwest of town. You can see it starts off on the bottom left of the image, very clearly a narrow tornado track. moving off to the northeast, pretty straightforward there. But if I shift the imagery to the northeast a little bit, and this is again just moving it northeast, I didn't actually move it very far, you can suddenly see we start getting downburst damage or starting to work its way in on the right side of the tornado track. And as we move off even farther in just a mile or so, suddenly that downburst undercuts the tornado track itself, and you start getting this much broader scale circulation, much wider tornado track, much wider damage track. And it's really difficult to see, where does the downburst start and the tornado end? Some might say it's over in here. If we shift it to the northeast a little bit more, it's really difficult to say there's much of a tornado there anymore. You can see this really just broad scale wind field. There's some really oddball stuff happening up here on the top of the imagery, which I'm not sure what this is all about. But you can definitely tell the circulation of the tornado opened up, and calling it a tornado would be very difficult to do at this point. So it ended probably somewhere here in the middle of the image is where you would call the tornado having ended and the downburst having begun. So great example from Muscatine, Iowa, of that transition. And then finally, assigning ratings. This is a easy example I found from one of our events in August of 2021, where we had tree damage here. You can see the damaged tree groves here to the south of this road. And we couldn't see any of this damage from the road. The tornado was initially rated EF0, but upon looking at this damage and comparing earlier examples for that type of tree damage, we determined that there was probably more EF1 type tree damage. So we eventually rated EF1 solely based off of the satellite data from the Sentinel satellite. And these are just some stats I put together. I was trying to go through some of our more recent events of how we've used aerial data, at least here at the La Crosse office. Starting with December 15th, the big derecho event. These are the stats I was able to get from both Des Moines and us. And we were able to augment over half of the tracks with aerial data. So we improved those tracks simply with the aerial data. And we found 8 additional tornadoes solely from the aerial data alone. So almost, you'd say 2/3 of the tornado tracks were either found or improved with the aerial data. And the example I showed for many of these case studies from April 12, 2022 here in La Crosse, which was technically our largest April tornado event on record, every tornado track was either augmented with satellite imagery or even found with satellite imagery. We found almost half with the aerial imagery alone. So wrapping this up, why take the time to do this? The biggest thing that I could come up with is improving storm data. And we can all sit here and rant about the limitations of storm data, but we have ways to improve storm data through improving our storm survey process. And storm data is just such the backbone of so many severe weather research projects, and so many of them rely solely on storm data for an important aspect of their research. And if we have ways to improve that, we should be working towards that. It also improves the imagery and the tracks in the DAT, which a lot of researchers are also gravitating towards, is the tracks directly in the DAT. So circumventing some of those GIS limitations in storm data right now. And finding these tracks and improving these events really does help further our understanding of how these events behave. I mean, LSRs are just point sources. They don't tell the full story of what actually happened out there in the field. And by doing that, you can correlate that with radar data better and advance our warning methodology and warning training as well. And really, in the end, maybe even improve our warning services or provide data I put in there to support the need for changes in those services, like finding those 111 damage tracks back in Iowa. We sat there and went, holy buckets, I don't want to have 111 misses document hitting towards us. So, maybe we need to look at changing those services. And finally, the last slide I had here was the example from that Boswell tornado. This is the story map that we made, where we showed before and after comparison data directly within the story map itself. And one of my favorite parts of the story map was actually going and doing this slider bar comparison with the actual imagery data from the damage assessment toolkit. So I had just 2 layers, one with the Sentinel data and one that had the Sentinel data plus. the damage assessment toolkit data. So you can actually just slide back and forth and see how the survey matches up with what you see in the satellite imagery. And it was really nice to, I think, just an informative graphic to put out there. And so that basically wraps up the talk here, and I can take any questions that you might have.